Day 423 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 2016, maximum difference between increasing elements. The difficulty level is easy, so you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Given a zero-index integer array nums of size n, find the maximum difference between nums of I and nums of j, i.e. nums of j is minus nums of I, such that 0 is less than or equal to I is less than j, and j is less than n, and nums of I is less than nums of j. Return the maximum difference. If no such I and j exists, return -1. All right, y'all, so that sounds simple enough, but let's go ahead and take a look at these examples anyway, just to make sure that we are doing this problem correctly. So in example 1, we have the input nums equals an array of integers 7, 1, 5, and 4. The output is 4. Explanation says the maximum difference occurs with I equals 1 and j equals 2. Nums of j minus nums of I is equal to 5 minus 1, which equals 4. Note that with I equals 1 and j equals 0, the difference of nums j minus nums of I equals 7 minus 1, which equals 6, but I is greater than j, so it's not valid. All right, y'all, so let's go ahead and break this down one step further. So as you can see, we took these two numbers right here, which is index 1 for I and index 2 for j. When we subtract j from I, or 5 from 1, we get 5 minus 1, which equals 4, right? And that's the maximum difference between increasing elements. It says right here, note that if we had I at 1 and j is 0, which would be this two right here, then we would get 7 minus 1, which would give us 6. But in this case, I is greater than j. Remember, it says right here, I has to be less than or equal to 0, or excuse me, greater than or equal to 0, but it has to be less than j, meaning, and this right here is dealing with the indexes, not the values of the index. So if we're at index 1 for I, that means if I is index 1, that means j has to be index 2 or higher. It can't be index 0 because 0 is less than 1, right? So this right here, when we see nums of I in the square brackets and nums of j in the square brackets, that's when we're looking at the values of the indexes. But when we're just looking at the letter themselves, that's dealing with the index themselves. It's not dealing with the value of the indexes. So the index of I has to be less than the index of j. And in this case, if we did 7 minus 1, j would be less than I, because it says right here we have to subtract I from j. We can't subtract j from I, right? So that's why in this case the output is 1 and 5, and 1 being I, j being 5. Then when we subtract j, or we subtract I from j, it would be 5 minus 1, right? When we subtract I from j, that gives us 5 minus 1, which gives us equal to 4, which is the maximum difference between increasing elements. So let's go ahead and take a look at example 2, just to or just in case they try to throw a trick question our way, because in example 2, there are no elements, right? If I and j, if no such I and j exists, we return -1. So in example 2, no such I and j exists. So let's take a look at it. In example 2, we have the input nums equals an array of integers 9, 4, 3, and 2. The output is -1. Explanation says there is no I and j such that I is less than j and nums of I is greater than j, right? So in this case, as you can see, it's all decreasing values. We have no case where nums of I is less than nums of j. We have no cases where nums of I is less than nums of j, right? Because every time we go down, it's decreasing, right? The array is sorted in decreasing order. So there is no increasing elements. Every element is decreasing. So in this case, we return -1. Now, let's look at example 3, where the two elements may not be right next to each other, but they still satisfy the requirements that the solution, or that, excuse me, that the problem gives us up here, these requirements right here. So in example 3, we have the input nums equals an array of integers 1, 5, 2, and 10. This time the output is 9. Explanation says the maximum difference occurs with I being 0 and j being 3. Nums of j minus I, nums of I gives us 10 minus 1, which equals 9. So just to break this example down one step further, we can see how this satisfies the requirement. So it says right here, I has to be greater than or equal to 0 and less than j, and j has to be less than n. So as we can see, in this case, I is equal to 0, right? So we have I at 1. I is equal to 0, but its value is 1. Index 0, value 1 for I. Then for 10, we have index 3 with a value of 10. So as you can see, it fits this requirement because I is 0, j is 3, 0 is less than 3, which means it fits this requirement. Then nums of I has to be less than nums of j. So in this case, we're looking at, so once again, this was the indexes 0 and 3. Now we're looking at the values, which are 1 and 10, right? So in this case, nums of I is 1, which is less than nums of j, which is 10, right? So 1 is less than 10, so it fits this requirement. So then we come over here and we do nums of j, which is 10, minus nums of I, which is 1, and that's going to give us the maximum difference, and it gives us a maximum difference of 9, and that's how we got our output of 9. So I hope that makes sense to y'all, and now that we understand the solution, the question, let's get into the fun part, the actual solution, y'all. Let's get started. Now, the first thing we're going to do is we're going to initialize the minimum value to the first element of the array. So we can declare a variable, we call it min val, and we'll set that equal to nums square bracket 0. And once again, that's going to get us the value of index 0. Boom. Then we're going to initialize the maximum difference to -1, which will be used when no difference is found, similar to when it says right here and similar to example 2. So for that, we're just going to declare a variable called max diff, and we could just set it equal to -1 for its default value. Now we need to iterate through the array starting from the second element. So we're going to say for I in 1 ... less than sign nums.count. We're going to open up the bracket. If the current number is greater than the minimum value seen so far, we're going to calculate the difference and update the max diff if it is larger. So we're going to say if nums square bracket I is greater than min val, we're going to open up the brackets and we're going to say max diff equals max, open up the parentheses, max diff, comma, nums square bracket I minus min val. Then we could come right here and we're going to say else, open up the brackets, if the current number is less than or equal to min val, we're going to update min val to this smaller value. So we're going to say min val equals nums square bracket I. Then finally, all we have to do is return the max difference found for or -1 if no valid pair exists. So to do that, all we have to do is come right here and say return max diff. Just like that, y'all. That should be all that she wrote. Let's go ahead and give it a run before we submit it. Make sure it runs properly because we all know how LeetCode can be, and it's accepted. So let's go ahead and submit it. Make sure it's still accepted after we submit it. Ooh, look at that, y'all. 0 milliseconds beats 100% of users in Swift. That's what I'm talking about. Those are the numbers that I like to see. So with that being said, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.